medcram.com.
Well, welcome to another MedCram lecture. Today we're going to talk about forever chemicals. These are technologically advanced substances that are used in all sorts of things today, like pans that don't stick, things that don't break down, foams in fire retardants, clothes, things that don't stain. Basically, better living through chemicals, things that make our life easier. And there's something about these structures, which we'll talk about, that make them that way. And unfortunately, because of that, they don't break down. They don't break down on purpose. And so, whereas normal substances might break down in a number of months to years in the environment and break down into their normal parts, these things stick around literally for thousands of years. And unfortunately, the science is telling us that these things can actually cause harm in living systems. So we're going to talk about what these are, where they came from, why they are the way they are, and what we can do about it. Now, the term forever chemicals actually came about 4 years ago by a professor at Harvard that we actually had here on MedCram, Dr. Joseph Allen, talking about ventilation, you may recall. But we also talked to him about these forever chemicals. And there's literally hundreds and hundreds of them, but we're going to talk about a few. And as you'll see, that's the problem, is that there are a few that get used, but there's really hundreds of them that can be used. So what do? Let's take a deep dive and look at what is going on. So as I mentioned, there's a bunch of these, but we're going to talk about primarily two of them today, two types. The first one are called PFAs, or PFAS, and that stands for per and polyfluoroalkyl substances. And another group is known as the bisphenols. Now, you may recognize this bisphenols. This is basically two and phenyl groups. So if you know what that looks like, it's a benzene ring with a hydroxyl group on it, coupled together with something identical on the other side. And there's something called bisphenol A. That's known as BPA. You may have heard of that. But there's also BPB. There's BPAF, there is BPS. In fact, there's over 200 of these types of bisphenols, basically with different groups attached on both sides. They have very similar properties. They're used a lot in plastics, but can have issues in the human body in terms of hormone regulation. On the other hand, the PFAS over here tend to use the carbon fluoride bond, which is a very strong bond, as the core of these substances. And so you'll have something called PFOA, which stands for perfluorooctanoic acid. And another one is PFOS, which stands for perfluorooctane sulfonic acid. And yet another one is known as Gen X. No, this is not the generation that was born from 1965 to 1980, but it's actually a substance. It stands for hexafluoropropylene oxide dimer acid. And we won't write that down because that looks pretty complicated. Just know it as Gen X. This is Gen X. As you can see here, there's a lot of these carbon fluoride bonds. These things are very, very stable. Take a long time for them to break down. Also, these things have a tendency to basically allow air to pass through without allowing grease and other substances. So they're great for coating things if you don't want things to stick. So it's used a lot in non-stick pans. It's also really hard to destroy, so it's used a lot in fire protection. It's also used in furniture, clothing, things of that nature. And here's a structure of PFOA and PFOS. Highly fluorinated carbons, and you can see some other substances as well that are also highly fluorinated. That's the issue, is that you can make almost endless combinations of structures that have lots of fluorine atoms connected to carbons. But the ones that are most commonly seen are the PFOA and PFOS. So what's the big news this week? In June of 2022, after being really pushed and prodded by an organization called the Environmental Work Group, which is a nonprofit, pushing the EPA to come up with better standards for monitoring these forever chemicals. The EPA finally says that they have found really no safe level for two toxic forever chemicals found in many U.S. water systems. And the reason why I say there that it's found in many U.S. water systems is that it's really not being checked in a number of different systems. And the two chemicals that we're talking about are PFOA and PFOS. and they've been linked to different types of cancer, low birth weights, thyroid disease, and other health ailments. And that's really the reason why we're talking about it here at MedCram. And what this article says is that the agency is now saying that any detectable amounts of PFOA and PFOS are unsafe to consume. So what has this environmental working group said? They've been actually tracking these PFAS chemicals in drinking water for some time because they're actually not officially regulated, and they've been very concerned about it. And recently, in the 2000s, there was an agreement between industry and the environmental groups to basically stop using specifically PFOA and PFOS. Now, this has to be very clear. They've stopped using those specific forever chemicals. But as we've said, there's hundreds of other chemicals that can work exactly the same way that is not PFOA and not PFOS. And so while they're not specifically using those chemicals, you can still get harm from other chemicals in the same group. So how widespread is this? Well, Scott Faber, who's the senior vice president of the Environmental Working Group, said that at least 1,943 public water supplies across the country have been found to contain some amounts of these substances, PFOS and PFOA. And there are likely many more that contain the chemicals, but we don't know because they haven't been tested. So the article goes on to state that if you actually test Americans, that more than 96% of Americans have at least one of these groups of forever chemicals in their blood. Now, of course, we know about the dangers of PFOA and PFOS the most because they've been studied the most. But there are newer replacement chemicals that have taken their place ever since they've stopped using PFOA and PFOS in manufacturing. And the biggest one that has taken its place is something called Gen X, as we talked about. And this has caused some issues in North Carolina, where there was apparently dumping of this chemical. So what exactly is going on? How are these substances actually interfering with our immune systems? And this was a recent article that was published in the proceeds of the National Academy of Sciences that was written by Carolyn Beans, who's a science writer. And she referenced this study that was published in 2012 looking at serum vaccine antibody concentrations in children exposed to these specific compounds. And what they found was that in children who had the higher concentrations of these substances, there was a reduction in antibody responses after vaccination. This, again, should raise some alarm bells in terms of the potential reason why we're seeing repeated infections with COVID-19 and perhaps other infections in industrialized countries where there may be higher concentrations of these substances. Again, this study only showed an association. Of course, there wasn't a randomized controlled trial. We would not do that with these types of substances. Interesting here in the results, when they looked at the maternal concentration of these substances as an assumption for what was going on in the baby, those that had twofold greater concentrations of exposure were associated with a difference of negative 39% in the diphtheria antibody concentration. When they actually checked the concentration in the child's serum by the time they got to the age of 5, it showed a uniformly negative association with antibody levels, especially at age 7 years. In another equation model, a twofold greater concentration of major PFCs in child serum was associated with a difference of basically half of the overall antibody concentration. A twofold increase in these substances at the age of 5 years was associated with an odds ratio of 2.38 to 4.2 times the likelihood for falling below a clinically protective level of 0.1 international units per milliliter for tetanus and diphtheria antibodies at age 7 years. That means if you had a higher increase in these concentrations, you're more likely to not get the immune response to these vaccines that you would normally need to have to prevent infection. So their conclusion was that elevated exposures to PFCs were associated with reduced humoral immune response to routine childhood immunizations in children aged 5 and 7 years. The article goes on to state that animal models and human studies have provided strong evidence that PFAS alter the immune system, diminishing the ability to fight disease or respond to a vaccine. So it's good that we're not making these two substances that we talked about, but it's not good that they're making new substances which may be as toxic or even more toxic than the two substances that we're not making anymore. It says here that U.S. companies no longer manufacture the two best known PFAS substances, but these legacy substances persist in the environment, even as thousands of others remain in production. So what is it that we can do about it? We know that industry was making these substances, and these substances were getting into humans. Now, ever since these substances have been banned in terms of their production, we have started to see that the blood levels in humans of these substances specifically are actually going down. But remember, there are still concentrations of these substances in the environment. And why would that be? Well, again, because these are forever substances. It literally takes thousands of years for these things to break down. But remember that just because industry can't make PFOA and PFOS, it can make other chemicals like Gen X or hundreds or thousands of other chemicals that do pretty much the same thing. And there are multiple ways that these substances can actually get into human beings. One of them is drinking water, but it's not the only way. And so there are solutions that we can employ to not only prevent these things here at the production level, which would be ideal, but also here at the consumption level. Really, the best thing overall would be to attack it here at the production level, because that would prevent these things from getting out into the community, into the environment, not only harming human beings, but also harming animals. However, because this is the best way, it hasn't stopped people from looking at other ways of doing it and preventing these chemicals from getting into the drinking water and making sure that the drinking water is safe from the standard of these chemicals. So the question is there filters that can actually take out these substances? Remember again that the majority of these substances are going to be seen in large municipal drinking water districts. That's because that's where these factories are generally located. And so it's not going to be favorable to depend on filtering these things out of the drinking water only to provide clean water, because it would place an undue economic burden on those that can least afford it. Nevertheless, there have been some studies to see how well in-home drinking water filters can completely remove toxic PFAS. And I'll put a link to this article in the description below so you can read it for yourself. Here are the key takeaways. Reverse osmosis filters and two-stage filters reduce PFAS levels, including Gen X, by 94% or more in water. Now, there weren't a lot of two-stage filters that were tested, so that requires a little bit further testing to see why they perform so well. The carbon block filters remove 73% of contaminants of the PFAS family, but there was a lot of variation according to this study. Some performed very, very well, others not as well. And the activated carbon filters that were whole house systems actually varied widely as well, as you can see down here on the third point. In fact, in 4 of the 6 systems tested, PFSA and PFCA levels actually increased after filtration. And the authors of this study said that the under-sink reverse osmosis filter is the most efficient system for removing both the PFAS contaminants prevalent in central North Carolina and the PFEAS, including Gen X found in Wilmington. Unfortunately, they also cost much more than other point-of-use filters. This raises concerns about environmental justice, since PFAS pollution affects more households that struggle financially than those that do not struggle. And I'll actually include the American Chemical Society publication assessing the effectiveness of point-of-use residential drinking water filters for PFASs here in the description below, so you can look for yourself exactly how they did the studies and what they showed. And I was able to find a carbon block filter that actually shows that they are certified to remove PFOA and PFOS greater than 95.5% of the time. And I have no financial interest in any of these companies. And remember that drinking water is only one avenue that these forever chemicals can get into our system. They are in our furniture, they're in our clothes, and they may be the reason why some of us may have immunodeficiencies. The studies are associative. We do not have the highest level of evidence yet to link those. but it seems as though the more we learn about it, the worse the news becomes. And for those of you who are familiar with MedCram, we actually talked to Professor Joseph Allen out of the Harvard Public School of Health, the man who actually coined the term forever chemicals, about this very topic. Listen as Kyle interviews Dr. Allen about why BPA-free products may not be all they're cracked up to be.
I want to ask you about some of the products that we all have in our homes or use every day. And I have a water bottle here that says BPA free on it. And when I read some of your book, when you talk about how some of these chemicals, it's like chemical whack-a-mole, I think was the term you used. So could you talk a little bit about that? Why something like BPA free may not give the security that we hope it would?
Yeah, so we're moving to the topic of chemicals. This is a massive topic that doesn't get enough attention. It's something I've been studying for a long time, and you'll really get me going because, there's a chapter in the middle of our book. I'm not trying to sell a book here, but it talks about our global chemical experiment. And I promise if you read it, it should shock you. It should absolutely shock you because there's an assumption that the products we buy are safe and that that if there was a chemical that was toxic, well, of course, it shouldn't be in your water bottle or my couch or my kid's child, car seat. But here's how it works. And here's the problem. There are over 80,000 chemicals in commerce. Very few have been tested for health and safety. And so what happens is we don't follow the precautionary principle. We allow companies to put these chemicals in commerce. And then if we, the scientists, find out it's harmful, they take it out. But what happens is they often replace the toxic chemical with a chemical cousin that's just as toxic. And we call this chemical whack-a-mole. And it's this never-ending game that's been played for decades. And BPA is a great example. So if you're a customer, you're well-meaning, you look at your bottle. Okay, there's two bottles. One says BPA-free. Well, I'll get the BPA-free one, right? BPA must be bad, even if you know nothing about BPA. And BPA stands for bisphenol A. It's a hormone-disrupting chemical that's used in some plastics. The reality is, though, BPA got a bad rap. And so manufacturers seized on this and they said, well, I'm going to sell BPA-free everything. They didn't just take out BPA. They took out BPA, but they replaced it with its chemical cousin, BPS, for bisphenol S. Sure enough, the toxicological profile looks exactly the same, darn near similar, to BPA. So in that way, they played a game with you as a consumer. BPA-free is great. That label might as well say contains BPS. BPS is starting to get a bad rap. You know what the replacement is? BPF. This goes on and on. We've seen this with pesticides decades ago. We see this chemical whack-a-mole in nail polish. We see swapping of chemicals in e-cigarettes. We see this in flame retardants that are in your couch and my couch. We see this with these forever chemicals, these stain-repellent chemicals that can cause testicular cancer that you find in nonstick pans that are used on carpets. And there was one that was labeled bad. Okay, that was removed, and it was just subbed in for another one. So this game of chemical whack-a-mole happens all the time, and we sometimes call it regrettable substitution is the less playful name for it. But it's another name I don't like, because it implies whoops, we made a mistake. It's a regrettable substitution. Whoops. This has been happening for decades. There's nothing regrettable about it. It's a knowing failure of the system and a loophole in our chemical policy. And here's where it's interesting for all of us and everybody. These chemicals, they migrate out of their products. And if you take something like these forever chemicals that are the ones that are in your nonstick pans and in your carpets and they're on our clothes, it makes things, water and soil just wash off these days. It's amazing. We love them as consumers. Well, these things are really pernicious. I mean, they last in the environment forever. I wrote an op-ed calling them forever chemicals and named them that 2 or 3 years ago at this point when that piece came out. But they're associated with these harmful effects, carcinogenic effects. They're called obesogens. They interfere with lipid metabolism. So we have all of these, known adverse effects. We keep using them, and we have this chemical whack-a-mole. And the problem with these forever chemicals is there's at this point, 6,000 variants. So what do we even study next, right? So as a consumer, we really have no chance to be like a thoughtful consumer and avoid these things because it's a totally broken system.
Any specific recommendations for people to help navigate this landscape of chemical whack-a-mole and finding products that are safe to use?
Yeah, so I think the first thing is all getting informed about this, right? Because I think few people know this is going on. Again, I'm not trying to sell a book here, but you could find, look up Forever Chemicals, look up this op-ed on chemical whack-a-mole. If you're interested, read that chapter, and you'd be really surprised. And then we can start asking for it. I'll say, from a systems standpoint, we're trying to address this through my Healthy Buildings program at Harvard with Harvard's Office for Sustainability. We created the Harvard Healthy Materials Academy. And what we're doing is we're starting to change buying practices. So instead of a company saying, well, here's something that doesn't have BPA, we're starting to ask and say, well, what else is in it? And by the way, we don't want anything in that whole class of chemicals, right? We're not going to play this whack-a-mole game. Forever Chemicals, we don't want any of them. I don't care what your next safe replacement is that you tell us is safe, that we'll find out is toxic. And we're having a lot of success. We have 40 pilot projects, over 40 pilot projects on our campus, where we're showing that you can design these spaces with great products that don't impact cost or time of your project. They look great, perform the same, and you don't have the toxic chemicals in them. So there's a way to do it, and we're trying to move that with the market. We partnered with Google 2 years ago on this initiative. Many other big companies are starting to put their buying power behind this movement to kind of rid the market of these these toxic chemicals that are in everything. They're in our deodorants and shampoos. I don't use shampoo. That's a bad example for me. But in our couches, chairs, they're all around us. So the way to do it is to move upstream and change the whole system.
Join us at medcram.com for more understanding in less time. Thanks for joining us, and don't forget to subscribe.